just do a PowerPoint, all that jazz. What you need to also write down is if I'm trying to go bigger, I'm going to move the decimal place to the left. If I'm trying to go smaller, I'm going to move it to the right. Go ahead and write that down as well. That helped me when I learned this in kindergarten. Kindergarten. Bigger equals left, smaller equals right. Because over 1 equals it. Does that make sense? Okay, so here we go. Here are some examples of what we're doing. So unit conversions are basically converting units from their base or from something else that you want to get to a base or to a completely different metric, all completely different. What you're going to see in Google Classroom, I'm going to show you this real quick here. When you guys are in Google Classroom, you will see something like this. Anytime. So if you look inside of your classroom, number 5, classwork, you're going to see in resources, which is the second tab, at the very top, engineering formula sheet. Inside of there is an engineering formula sheet that looks like this. This formula sheet is 11 pages long, and you won't need to know everything. This is for all 4 years. We use the same formula sheet for the whole entire program. What you do need to understand is that on page 3, I believe it is now, yep, page 3 you'll see conversions as well as prefixes, and that's what you guys are going to focus on using today. So if I minimize that and go back, I've already put it over here on the right just so we can reference to it and talk about it today. But realistically, you're going to be able to use this formula sheet on any test that you take in this whole entire program. Okay? Even on the EOC, you'll be able to use it. So you don't need to memorize any of this. You just need to know where it's at and how to use the formulas that are given to you. Make sense? Okay. So let's do the first one. Some of these are easy, some of them are hard. If you look over in this chart, you're not going to see any base units. Base units are your grams, your meters, your, that kind of stuff. So those are all right here in the center of these two brackets or tables right here that you see. So if you go over here and you say 103.2 centimeters. Centimeters is right here. It's a smaller number, less than 1. 2 meters. Meters is in the middle. So like I said, if you're going to meters, if you're going to liters, if you're going to whatever, those are all in the middle here. So if I'm going from centa to a base, which is meters in this case, you can do all this math and you can say 103.2 centimeters. This is your given, multiplied by your desired, which is meters, divided by your centimeters will give you your desired. That's math that I don't think is necessary. You can also just move the stinking decimal place. So if I go through here and say 103.2 centimeters, centimeters is 10 to the negative 2. This number indicates how many times I'm going to move that decimal place. This little chart, bigger equals left, smaller equals right, is going to tell me in what direction I'm going to do it. So if I'm going from a small number to a big number, I'm going bigger, I'm going to move it to the left. How many times? Twice. 1, 2. I'm given my answer of 1.032. Easy enough? Next one. Kilo. Kilometers to centimeters. If I go over my chart again, kilo is a big number. It's greater than 1. Has 3, 10 to the power of 3, and it says that on the little chart right here. It also, again, you can do all this math. I don't think you necessarily need to. It says 3. Centa is then 2. 3 plus 2, because we're going from kilo all the way over, and like I see my mouse here, kilo all the way over to centa. We're going from a big number to smaller, so we're going smaller, which is to the right. If you look at this, we're going to move this decimal point, not 3, but 3 plus the 2 to give us 5. 1, 2, 3, 4, 5. What does that give us? 500 centimeters. Does that make sense? Now again, you can do it mathematically, and how they do mathematically, again, it's kind of a waste of time, but you do think. Kilometers is already given, multiplied by our desired, which is meters first, and then they divide that by kilometers, which is what we're trying to get rid of as far as units goes. Then we take that 5 meters, and then we get this is now our given, desired is centimeters, given is meters, and then you would divide 5 divided by 10, which in this case is going to give you 10 to the negative 2 power, which will give you that number. That equals this. Anyways, why am I going to do all this math when I can just move the decimal place? Make sense? Okay, next one. Same exact thing, but now it's a little bit different because it's all on one side. So we're going from hecto, which again is right here, hectoliters, to megaliters. So we're getting it from big to bigger. So we're still, if we're getting bigger, we're going to go to the left. If we got hecto, which is, if over in this little chart, is 2, right? And then mega, which is 6. What is the difference between 6 and 2 number-wise? 4. So we're going to move this 4 places over because it's going from bigger and it's on the same side of the chart. So hecto right here and mega right here. Those are 4 differences. We're getting bigger, so we're going to go to the left. How many spots? 4 times. 1, 2, 3, 4, and you see your answer is right here, 0.051967. Pretty straightforward, right? Okay. Next. Now what if we don't have like units? What if we have things that are like yards to feet? Now we're going to use this conversion chart up here on the top that basically gives you everything you need to know numeric-wise. Your givens, your standards, right? Your, what do they call it? Constants. So in this case, 1 inch is equal to 2.54 centimeters. It tells you right here, right? It tells you that 1 yard equals 3 feet, whatever. Well, we're going to use this one actually. 1 yard equals 3 feet. 17.2 yards, and they're trying to convert it 2 feet. There are 3 feet in 1 yard. Given, desired, given. There are 3 feet in 1 yard. You multiply 17.2 times 3 to give you 51.6. Next. These ones are 3 feet 7 3/4. On your activity today, it'll look like this. It doesn't mean minus. That means that they're connected. That means that it's actually 3 feet and then another 7 3/4 inches. Okay? 2 inches. So we have a feet, we have an inches, we need to get them all to inches. All you have to do then is take the 3 feet. This is what you're given. Your desired is in inches. Your given is in feet. These cross multiply. 3 times 12 is 36. This one's already in inches, so we can just add that up. 7 3/4. 36 plus 7 3/4 equals 43 3/4 inches. Make sense? They're also going to ask you today, on that exam or on the activity you're doing, they're going to say to make it in decimal feet. What that means is you need to change this inches to feet. You need to make it a decimal in order to make it so that it is decimal feet. Yes?
If it's something like 5/16 of an inch, or
right.
something that has a hard decimal point,
yeah.
Do we get to use a calculator?
Yeah, absolutely. You can use a calculator anytime you want. Let's say we want to make, and this is not on here, and I want to make sure this is clear. If you do 7 3/4, and it's in inches, and they're trying to say, go to decimal feet. Okay? All you have to do is, how much is 3/4? As a decimal. 0.75, right? So that's the same thing as this. Does that make sense? Now this is still in inches though. 7.75 inches. They want it in feet. So all you have to do is what? Divide by 12, because there's 12 inches in 1 foot. So in this case, it is basically from here to feet over inches. There are 12 inches in 1 foot. That divided by 12 will give you your decimal feet. Okay? I don't even know what it is, so we'll see. 7.75 divided by 12 give you 0.6, and you can 0.65, just round up, feet. They'll ask you that on the test today, so make sure you guys understand what that's saying. Okay? On the test. The activity. My bad. Come over here, 34.7 inches to centimeters. Now we're going from inches to centimeters. There's a whole different thing. Now we got an inch to a meter. That's not even close. So again, we got to look at the conversion chart. Inches over here, there's 1 inch and 2.54 centimeters, so that helps. We have inches, which is our given. Desired is centimeters. Given is inches. These cross multiply. 34.7 times 2.54 gives us our 88.1. Next one. What happens if you have to do it twice? Inches to yards. Well, inches over in the conversion chart doesn't go to yards. It goes to centimeters. And then it goes from yards to feet. The common unit in this case is going to be inches and our feet. So we need to first convert to feet so that then we can eventually convert to yards. So in this case, you're given the 345.7. Given, desired is feet first, and then you're going to be given inches again. There's 12 inches in 1 foot. You divide 345.7 divided by 28.8, or divided by 12 to get 28.8. Once you're in feet, you're given this. You're desired to get into yards. Then you're going to go back into what you're given as feet. You divide, in this case, 28.8 divided by 3 to give you the 9.602. And now because these are crossed out, you're left with yards and your answer. Make sense? The last one. These are ACT questions. There's going to be 2 of these on your activity today. So let's say 55 miles per hour. Let's say you have these 2 now, okay? And you need to convert it to kilometers per liter. You have to pick one first. So all you're trying to do is get the numerator and the denominator to cross out. So in this case, gallons, and then eventually we're trying to get that answer, and we're trying to get miles to cross out, right? So if I'm left, and let's just start out with gallons. How many miles are in 1 liter? Or how many gallons, or whatever the case may be. If you look over in the chart right here, you're going to see gallons, and you're going to see right here, 1 liter equals 0.264 gallons, feet cubed, and ounces, whatever. 0.264 gallons. So we're saying that 1 liter equals 0.264 gallons. Why are we putting it this way? Because we want to try and get rid of this gallons. This is our given, and these are going to cross out. So they'll cross out. You're left with liters. We got one of them, and it's in the denominator, which is, this is the same as this, right? That's in the denominator. We're good. Let's get this kilometers now. So we got to get rid of this miles. So how many miles are in a kilometer? If you look back up at this thing again, you're going to go a little distance or length. 1 mile equals 3.28 feet. That's not going to help us. I'm sorry, 1 meter. 1 mile equals 5,280, right? Doesn't help us either. Let's say kilometers. So right here, boom. 1 kilometer equals 0.621 miles. So take 55, multiply it by 0.264, you get your number, and then you divide whatever that number is by 0.2621 to get your inevitable answer of 23.4. And that's it. Okay? I had to show that to you. It's over. Don't worry. The pain is off. So now what you're going to see is in the activity, looks like this. Inside of Unit 1, you're going to see unit conversions, and inside of there, you're going to see this activity. One thing that a lot of people are screwing up on is this, and I want to make sure this is clear. Like A, kind of throws people off right out the gate. If you look at my screen here, you're going to see 4.567 trillion meters to gigameters. That's kind of confusing. You got double units here, right? I would take it, and they even put it in parentheses, I would put the trillion as a real number and then make it meters, because now all we got to do is move the decimal place, how many ever power the gigameters is. Does that make sense? Yeah. Okay, so just be aware of that. There's another one that says billion meters or something like that. Make sure you put it as a full number first before you start converting. Okay? That is it. The rest of the time is yours. Make sure you guys put the thing in your engineering note. This is what you're working on. All of them. There's 1 through 3. If you don't finish, it is for homework. Okay?
Where do we find that?
Google